marketing term. But at some point, we also have to kind of say, like, well, how are we actually going to implement this, and what makes an agent different from a chatbot? And we're going to see is we're going to talk about tools being like a very, the most important part, that we actually need to be able to do something. And that might be making API calls. And then at the end of the day, as opposed to just running an LLM once, we need to keep running over and over and over again, so that the AI is working towards our high level goal that we give it. So we're not involved in every small detail like you would be with a chatbot, because that's the advantage that you get with AI agents. So I think this immediately leads to this question of, what are tools? And at the heart, we're talking about, tools are really just running code. We want to have our LLM decide to run a piece of code. So this could look like accessing an API. So we could say, I want to book a flight, right? And all of a sudden, if I just used a chatbot that couldn't access tools, it could maybe tell me that, I might want to ask it about planning a vacation, but it wouldn't actually be able to, book that flight. And a lot of these aren't as risky, I would say, as maybe doing something like that. They might be running a more complex search, or writing to files in a local file system, or running some internal tool in a more complex, maybe generating a graphic with, some API that you might already have, like in a data journalism example. And a lot of these, I say, do things in the real world, but I would say still a lot of these tools are about, complex ways of accessing data. And so we'll see that in the example, where one of the tools, there'll be two tools in the example. One of them is going to be a news search tool that uses an API called newsdata.io to actually do a search of the news of the day, and then an email sending tool where we're actually going to at the end of the process say, okay, we want to actually send this email. In my kind of example, I was thinking maybe we don't want to immediately post the AI generated article. I think that's kind of risky, and we'll see with the quality of this agent. I definitely wouldn't immediately post it, but saying, okay, we're going to send off that article for review via email. And one thing to remember is, even though we're talking about saying, okay, this runs code, at the end of the day, this code could even be invoking other agents or running prompts. So it's very open-ended, and this leads to a lot of different patterns. So one thing when we're talking about tools and loops, and later we're going to talk about state and a few other topics. One thing to keep in mind is that's almost why I think that people kind of avoid the specific details of agents until they go to implement them, because when you actually get into the implementation patterns, it looks a lot like writing software, but where the step that involves the LLM is in some ways less reliable than what you might have with traditional software. And so I found that really makes the development process different from writing software. But at the end of the day, an LLM is a model, and when we're building an agent, we're building a piece of software that's using LLMs and then invoking other pieces of software, and that's where tools come in. And specifically, one thing I would take away, especially to kind of just understand the current state we're in, and what you might hear these things, is the model context protocol is what we'll use in this example, and this is a standard for exposing tools that has been OpenAI and Anthropic, and basically every modern model has really been trained to use the model context protocol. And this we'll see in the next slide a specific example of this. But I would say it's really important for tool running. Almost like standardization is very important, because we need to be able to use a bunch of different tools, and the model context protocol also is just a way to expose those tools in the same way APIs became, kind of a universal way for people to get data. This is a way that allows agents to discover tools. And then skills.md I just wanted to mention it here. It won't be in the example that we see, but especially if you read about, Claude Code or OpenClaw or something, skills.md is another way to define actions that your agent can take. And it's a little bit more flexible. And later, I think after I give the presentation, I'll kind of open up an example of skills.md and kind of, but if you just have heard of these, think of both of these as ways that our agent is actually able to do something in the real world. And that's this very, very key component to having an agent. If it's not able to invoke some code and run something, it's not going to be very useful. And then if we tried to run it in a loop without tools, we very quickly would run into, after just a few iterations of a loop, needing a human being to start doing things instead of having the agent do it. And so that's kind of the first. So tools are definitely this first big idea that I want everyone to take away of saying, like, what makes an agent an agent. And here we have an example, and this is the one that we'll see in the example later, where we're doing a news search. And basically, all these tools, it's a lot of it is about the fact that it's exposing metadata on top of some existing code. So if you see, I have a name that I pointed out here that's defined in my tool. I have a title, I have a description, and so all of those things are going to be important. Particularly the description for the agent deciding which tool to use. And that's where this sort of standardization allows, the most recent models are really trained, especially when they say they're trained for tool use or they're trained for agentic use cases. A lot of that revolves around them being trained to choose the right tool to use. And then equally important, we have this idea of like an input schema and an output schema. So one of the brittle parts, if we tried to build an agent, but we didn't, standardize input and output, is we constantly be getting the wrong output out of the LLM to pass into the tool and then not be able to deal with its output very well. So in this case, our input schema is going to be the query for our news search, a start date and an end date to give a range for when we're searching the news. And then as an output, we're basically going to get an array, a list of results where each one has a title, an author, and a description. And so these, if you see like that z.string, z.array, these are all types that really formally, tell our LLM exactly what format the data needs to be in coming in and out. And then finally, we do need to define in our tool what's the code actually doing. In this case, we're just calling this function called news search. And later, when we actually walk through the code in the demo, we can take a look if people want to see, like, okay, what does that API really look like? But at the end of the day, this function is nothing new with AI. This would be, in this case, calling the newsdata.io API to do the search itself. So that's the first big idea, is tools. Actually, let me see, before I go on, are there any questions about that? Otherwise, I'll just kind of keep going on and on.
Not yet, Steve. So
not yet. All right, cool. Keep going. All right. So yeah, so then this is sort of the second really a big idea. So we have these tools that our LLM can invoke, but the second big part is we don't just want to run the LLM once and have the model produce an output. The big idea is we want to give a pretty high level goal to our agent, and then have the agent keep running over and over again until we actually finish that goal. And when we actually get into what happens in the loop, there's going to be a lot of different patterns, and we'll talk about one or two of those later. But the big idea is we definitely need to have some way to tell when we're done, some sort of end condition. And then the second one, and this is maybe less technical and very domain specific, but we really want to make sure, as we're kind of thinking, okay, is this agent going to make sense? To understand that the more narrowly focused that we make an agent, the less that it's just very broadly scoped like a chatbot is, the easier it's going to be to sort of guarantee that as we go from one step to the next, that we're kind of on the right path. And so there's definitely a lot of trade-offs going on. And ideally, we'd want an agent to be very long running while always doing work that is really valuable. But I think, what I found personally, I think is, generally true, that the longer running an agent is, and you see this with coding agents, that it's hard to make a really long running agent efficiently do what you want to do, because you have less opportunity to steer it. So if you're using a chatbot, you can almost think of it as there's kind of this loop where it's, you're giving it a prompt, and then it's coming back with a response, and then you're giving it another prompt, and it's coming back with a response. And so you're very tightly in the loop And that requires a lot of effort on your part, but it also means that you're constantly steering it in the right direction when something goes wrong. And the challenge is, as we build an agent, the longer running we want this to be, the more we need, and really is domain-specific ways to keep making sure automatically that the agent needs to know that it's on the right track. And there's a few different, depending on the domain, a few different ways to do this. But one metaphor that I kind of like is almost like a tennis game, right? If I'm working with a chatbot, it's like two people playing tennis, and I hit the ball to the chatbot, it hits back to me, and bam, we go back and forth. And with the agent, it's like it's hitting the ball against a wall, and it's if there, as soon as there's some issue, all of a sudden it's either going to struggle and use a lot of, like, pretty inefficiently do a lot of prompts to try to get itself back on track, and then be pretty expensive to run, or it's going to require a human being in the loop. And so especially using Claude Code, for example, or I've been using Mistral Vibe, which is similar. You really have this feeling of like, okay, I've got to, even though this is an agent, I've got to be constantly communicating with this and steering it, and in particular reviewing all of the output. And so that's something just to really keep in mind. As we're building agents, one statistic I read recently is like enterprise, like kind of business workflow related agents, maybe in customer service or HR or something, often will run under 10 iterations. The agent isn't running overnight or running thousands of iterations to get to some goal, because it can't reliably do that. And what you're seeing is with something like OpenClaw, where that's kind of the whole point, is that you just kind of give it access to everything and it just kind of runs forever, that there's huge risks involved. And so you have these trade-offs. And so yeah, if we take tools and take the agent loop, these are the two really, really core ideas. And the idea here too is if we might get more complex patterns where we even have an outer loop that controls the overall flow, and then some inner loops that are working on specific tasks. And most importantly, though, if we're thinking of as we go through each iteration of the loop, it's going to be some combination of invoking the LLM, invoking some set of tools, and then updating. And this is where we have to update the state that we pass on to the LLM the next time and continue the process. So to kind of give, I wrote some pseudocode here because I want to make it like when we look at the complete example, the whole code, it's not big, it's about 350 lines of code. But I wanted to make sure that when we, kind of take a step back and look at, it's running something very similar to this, where we start with some state. In this case, very, very simple. We're going to have done is going to start as false, so we're not done when we start, and then we're going to have basically like a chat thread that starts as empty. And the idea is with each iteration of the loop, until we're done, we're going to keep looping over and over and over again. We're going to call the LLM, and that's going to have the prompt that's specific to this agent, as well as that state that keeps getting updated. And in this case, when we call update state, we're going to add the response to the thread. So very, very similar to a chatbot in this example, where the entire state is just the chat thread we've had so far. And then in this case, we say, okay, we run the LLM, we get a response. We then say we might use a tool and then get a response back from the tool. And that might be something like news search or sending the email. And then finally, with the output of the tool and the LLM and the current state, we're going to update that state. And then we just, keep looping through this until we, eventually we need that update state to actually make a decision saying we're done with this. And that can look a lot of different ways to decide, being done. And then that's it. I mean, at some very, very simple level, this is what an agent is. And it's only the fact that, like, when you actually try to do this in practice, that, trying to kind of keep it on rails and not veer off course is a challenge. And so kind of the first big challenge that we have doing this is actually managing the state itself. Because in this simple example, where we say, okay, we keep this whole chat thread, that's okay, but it's not particularly effective when we have much more domain-specific problems. So in this case, we're trying to write an article. I want state that actually manages the research, the outline, the drafts. I want those managed separately. I want the state to really, really keep separately what the original instructions were. I want the state to be able to say like, what were the steps we did before? And so that's why, I put this as saying like, it's kind of the most complex part of the agent design. And this is, for anyone who saw, managing state is just usually where the rubber hits the road in any software system. But here, we also have to kind of deal with the fact that this weird trade-off where as we kind of try to solve problems by increasing the complexity of the system, which is just sort of the natural way, we run into some error, we run into some new problem, and we add stuff to it. We often get a lot of additional state, and it's just sort of the nature of LLMs. The more context you're passing into them, the more you start having new failure modes, right? So one of the tricks, you can get into this trap of just kind of like increasing complexity and everything breaking. And it's really important as you go to kind of rein that in and be judicious with deciding what states actually get passed to the next thing, and managing complexity. But at the end of the day, when I kind of, just empirically kind of going through and iterating, it feels a little bit like, okay, I always need what came before. And so I'm always gonna be taking some of the history, putting it in, but then also some of this stuff is more about, I'm gonna say writing software. We'll see that with an example with word count, with the essay where, I put as a very first class feature, I wanted to be able to say, here's the approximate word count for the article we're writing. But LLMs are very, very bad at knowing the word count in the context. But it's pretty simple to write some code to do a word count. And so that kind of leads to the next related problem to state. But this idea that as the state gets bigger and bigger, if we just have this naive chat history, it's going to get bigger and bigger very quickly as we run the agent longer and longer. And so it's this kind of idea that, if we run 4 or 5 iterations and that's it, we might call it an agent, but it's not this maybe, as valuable as if we could have it run for a few hours doing something. And so we've got to really aggressively figure out, how do we set, we've got a fixed context window. So we can only pass so much into the LLM each time. And so as we either have a large set of documents, so for example, like style guides, or, let's say I want to feed in every article that I've ever written if I were a journalist, suddenly you can't just naively do that. And so one of the things is, even a lot of these modern models have let's say, million token context or 256K, something like that. But what I found is you nowhere near that limit, you start introducing new failure modes. And even if it's at the margins, so I found that even going above like 20 or 30,000 tokens in the context of something like word count, if you wanted to have the LM do that, causes the quality of the output to go down. And so then it really leads to this almost like death spot. It's like, well, once you're trying to do a long running flow and some of these steps start failing because the context length is too long, well, with every step you take, you're probably, if you kind of have a naive solution to managing context, you're only making that problem worse because you're adding to the context. And so it might stop following instructions as well. It might, not, you might say, okay, I asked you to never have M dashes, or some of a very stylistic thing maybe, and suddenly it just fails to do that. And the other thing with an LLM is it might confidently come back and say there are no M dashes as you start approaching that context limit. And again, it's that hard to predict when it will happen. Part is, with software engineering, and definitely like with semiconductor, like you want determinism. I mean, determinism allows you to debug things, and the world isn't deterministic, but the more you have control, the better. And if you don't spend a lot of effort, engineering effort, and domain expertise to kind of figure out how are we going to manage context, you start just having these failure modes that just kind of pop up. And it just speaks even to this idea like with software, you need testing, and you need, in this case, like evals. But that's where it really makes, building an agent is not a small undertaking, because in addition to you're writing a piece of software, you need data scientists to manage that data in those evals, and you definitely need domain experts working closely. We'll see. I mean, after I do the presentation, we'll see what people in the audience think of the agent. But I wouldn't, because my domain expertise is not, I worked with Flavius on this and everything, but it's I'm not a journalist. that it really, if I had been working with a journalist every day and spent months working on this, you'd see a better outcome. And so I think those three things of you need, writing software and using the LLMs and the prompts, managing data, and then having domain experts actually go in and be part of that process. So we kind of talked. Okay, you got tools and loops and throwing in a loop, and that's really what makes it an agent. You have these challenges that emerge with state and context management. But the other thing is this idea that while an agent runs in a loop, there's a lot of patterns, and one of them is as simple as, well, let's just sort of have one really, really complex prompt that kind of deals with all situations, and sort of just leave it up to the LLM to kind of decide what to do next, and have this very, very open-ended, approach. And in some ways, it sounds really nice, and it's sort of this movement towards like AGI, I guess. And it seems like, okay, well, I want to have some emergent problem that we've never dealt with before, and just have the agent be able to solve it. But in practice, a lot of times, you have some process, some business process, or in this case, writing an article where you already have a set of steps and a process in mind that you want it to do. And in my experience, maybe like a year and a half ago, when I was first playing around with creating agents, that was I was really excited about that idea. It's like, it's going to save me all this work, and I just kind of let the agent loose on this large problem and have it run and it run and it run. And that sort of non-determinism really makes it like an intractable problem. And so a solution that you see in a lot of like enterprise agent workflows, and definitely like when I'm doing with semiconductor stuff, this is the approach I take. And then what we'll see in the example is you really want to have this agent follow a workflow where you have a set of steps and you separate them out and create modularity. And so in this case, we're going to have steps like do research, write an outline, write a draft, review the final version. And all of those steps are going to be easier to test individually. And as I think it also makes it easier for domain experts to look at it and to say, oh yeah, this is what I would do. And so if for example, you were automating like an HR workflow or something, it's like, okay, we've already been doing a workflow. We know that, okay, we've got to like get the data from this API to, maybe, onboard a workflow for like onboarding a new employee involves a certain number of steps. Some of them might fail. So unlike a fixed program, our agent still is going to need to be flexible, right? But it's going to be flexible within the context of a workflow. And then part of that is this idea of gating, where after each step, and definitely at the end of the workflow, we want to review the output. And in the best case, we're going to have a prompt that runs specific to the step that we're doing to sort of check, so after I run the research step, I then might want to run a gating step where I really say, okay, are all these sources real and they weren't hallucinated? Do we actually get this from the API? And so we kind of say like, okay, we have this agent, but instead of being super open-ended, we're going to have a workflow. And then very specifically, this finite state machine pattern using a manager is sort of my go-to. And again, this is where, there's other patterns that we could use to build agents, but the concept of a finite state machine is you have a very fixed finite number of steps that you do, and very specific rules to say, how do we transition from one step to the next? And we'll see, at some level in software, again, like my background, finite state machines are very concrete things where it really has very specific rules. In this case, we're going to leave it up to the LLM with a prompt, and the idea of a manager prompt to really go ahead and say, okay, how do we know which step to take next? So basically the pattern is going to be, we have these steps like write an outline, do research, and then we have this one step that I just call manager, and that's going to run in between every step. And basically its job is simply to decide, what step do we take next? And it could be, a manager could get more complicated than this, and maybe really handle some of the state and context management as well, where maybe it's not enough to say just what step to take next, but maybe kind of glue between these steps where we might need to, choose what database to retrieve data from or something like that. And yeah, just by having this very, kind of specific pattern, it makes it a lot easier to reason about what's going on and allows you to debug it, as opposed to simply, kind of having an agent that we have to look at every single thing it's running, and kind of it can do anything. And again, it's going to improve. It's also going to be more modular, which is better for testing, and more deterministic, because now we're separating out all these prompts. So each state's going to have its own prompt, rather than sort of like one giant mega prompt that has to deal with every single thing that our agent ever needs to do. And that also, again, creates often like a context problem, where it's harder, I found at least, it's harder for the LM to follow instructions correctly as we start pushing that context limit, and simultaneously have a lot of complex reasoning in the instructions itself, where we might have to say, okay, if this is what the state currently is, and this, then look at this other rule over here to decide to do this. That ends up, I found, like breaking at some point. You use the context, and suddenly it follows instructions wrong, and then breaks the whole process. By using this finite state machine, we know that, well, if the manager decides to do research next, we're doing research next. And it means research is sort of this atomic thing that's what the research prompt does. And okay, so those are, I think of those as these really, really core building blocks that are going to be true for any agents that are built. And just to kind of really say this over and over again, but to recap, we really have to have tools that are invoked and a loop for it to be an agent. Once we do that, we start having this problem of managing state and context. And then we really need to decide on a specific pattern, in addition to just being in a loop to use, so that we have something along the line of a workflow if we want reliability. And in this case, we're choosing this finite state machine manager pattern, but there are other patterns that one could use. So now I kind of want to talk about just a few other things with agents. So one is really just like, so how do I know if I should even build an agent in the first place? Because if the goal in the short term is to save time, the agent isn't a silver bullet. It's something that actually requires a lot of effort to build. And so one is, I remember like when Flavius and I had some of those calls, he had a lot of these use cases that seemed really like they were well suited for agents. But then when I actually asked him, like, how often do you do this? So for him, even, if he's doing a very deep, investigative journalism article, writing the article itself might not happen that frequently. And unless you're a large newsroom, you really can't amortize the cost of, if you're writing 2 articles a year and putting in hundreds of hours of research and interviews into each article, maybe writing the article itself actually isn't the bottleneck. And it might be a task that is difficult to solve in the first place. So the first thing is, you definitely want, the more that tasks are repeated often, the more you can afford the effort for the domain experts and engineering and data to kind of say, it's worth it for us to put all this effort into building a narrow agent to solve this problem. So a good example is customer service agents. I know one of the like pay now, buy now, pay later companies they had a good case study where, they built an agent for customer service. They laid off a bunch of their customer service people. I found I'm not usually very happy with customer service agents, but then when they kind of gave the statistic, like, well, we handle something in the millions or tens of millions of customer service queries every year, it makes sense for them to at least try to do that. That's the type of scale where it's so obvious to do it. Another one is, if you can, when something is very, very repeatable, if it is truly deterministic, if it is just an algorithm that a program could already do, a regular program, piece of software, is going to be way more deterministic than having an LLM in the loop. And so I think it's one of the reasons you're seeing, for example, like Claude Code has become so popular and such a big deal, to the point where it's like moving markets, is because actually being able to have a coding agent generate code to solve a specific problem is going to be a more reliable solution, where essentially, if the code doesn't work the first time, you're still dealing with the domain of, an engineer or someone in the company, working with Claude Code and iterating on it to get it to work correctly. You're not running into the problem that the LLM is actually in some user-facing, when it fails in front of the user, like something like customer service, or it fails in a way that even in internal processes like HR, We say, oh, I could just have this, submit this tax form or something. Well, that's now a risky operation. And so kind of, the other one is to say, like, what value are we getting out of the LLM itself and not just, something that can be done with code. And then I think the other one is when you need to have a lot of resources dedicated to it across, engineering, data science, and whatever the domain is that you're trying to solve. And so you've got to say, like, we have those. So if you're a small company, I remember about a year ago talking to someone at a law firm, and they were like, oh, we have this whole floor of this building. I'm like, oh, so you've got a dozen lawyers. Well, that's actually not a very large scale. If you're in a big law firm that has thousands of lawyers all over the world, then suddenly you might have those resources to say, let's try to build an agent to do something. But even a company with a dozen people, you have to kind of really decide, are we going to deploy all these resources? And unlike, I feel like even with writing software, it's hard to predict how long it takes to build software, but generally you kind of know this is what we're trying to build. Here's the goal here, and we kind of know that it will work. With LLMs, I find that you really can't take it for granted as you plan ahead that almost anything will work or how long it will take until you actually dive in and do that. And so you have to treat it, I almost view it as treating it like it's a capital expense, and one that could fail and one that's a high risk capital expense. And so, for me being like, well, this is a startup where this is what my company is doing, there's always a chance of failure, and that makes sense. But if you're like a small newsroom, you have to weigh that and say this is going to take a lot of effort. And then I think the other part of that is if the risk of the agent failing is medium or high, then I think it's also a big challenge. Like where the low-hanging fruit is where, a large company that has a lot of resources and you're finding a use case where you're like, okay, well, if this doesn't work perfectly or this works 90% of the time, that's good enough and it solves, some problem. And I found some examples like customer service sounds like a really good example because it repeats many times. But then when you say, well, if we have a single bad customer service experience, we might lose a customer and those might, customer might churn out. And so there was one SaaS company that I won't name, but like I used them for 10 years for some basic infrastructure stuff. And suddenly they replaced their customer service department with a chatbot that was not good enough. And it was pretty good. I was impressed with it for the first, 10 minutes until suddenly I had a real technical problem and it wouldn't escalate it to a human and I just couldn't solve it. And so it was one of those things where I just said, okay, well, that's it. I'm moving to another company. There are competitors here. And once I switched to another company, I wasn't going to put in the effort to switch back. And so I think, risk has to be viewed, by the company, by you to decide. But I would say find things where those risks are low, and that's where agents, are the most valuable. And then kind of building on that, this idea of, okay, well, if we're not going to build an agent, how do we kind of solve our problem? And I think this first one, use an existing domain-specific agent. This, I think, especially going into the future, I think you're going to see this more and more, maybe in 1 to 2 years, as sort of the more, you have some startup that solved that problem in your domain. So I think you're seeing there's stuff like Claude Code, where I could say I want to write my own coding agent, but man, Claude has put a lot of energy and cost into building this agent for coding, and that's what you see people use, and that makes sense. And I think especially in journalism, I wouldn't be surprised. I have no idea, but for example, like AP, it already seems like that would be a perfect fit for them to say, okay, we have this agent that uses our style book that, it just seems like a good fit. And so I think in, newsroom examples, there might in the future be more domain specific agents. Again, where I'm coming from in semiconductors, I see, there's just a bunch of startups entering the space to build these agents. So I think that's something to always keep in mind, or, like law, there's a lot of, medical and legal specific agents. So kind of starting there of saying, is there something out there that I could try using? Another approach is to really say, like, well, if I'm only doing this a small number of times, it just isn't worth the effort. And at the end of the day, if I want to leverage using an LLM, I should just use a chatbot. And even if you end up doing something 10 or 20 or 30 times, I noticed this with some of Flavius's use cases, and it was my experience running an education company that as a startup, I'd kind of over automate early on. And it took me a while to learn that, like, even if you're doing something for every customer you have, we had about 100 customers a year, or 100 customers, and I got tired of like sending them an onboarding email every time. So I said, okay, I'm gonna automate this. And when I looked back in retrospect, it was like, sending 100 emails over a couple years, I could have just done that, and it would have taken less time. And so I think that's something to always keep in mind, that if you're getting value out of the LLM, maybe the solution where you're copying and pasting, it might actually still be the best solution, even if it feels like you're repeating yourself. You have to repeat yourself a lot before saying, okay, we're gonna just build our own agent. Or maybe saying, okay, I'm repeating this a few times, I'm gonna keep a lookout for that domain specific agent that comes out in the future, while still leveraging the LLM. Another approach, I think, again, this gets back to, if you're not actually taking advantage so much of the LLM, writing code to do it, if you're a software engineer, or now with something like Claude Code, maybe say, okay, I'll give a shot at having a coding agent write a piece of code that continuously solves that problem for me. And that's particularly true where, if the input is very structured and isn't natural language, and the output is very structured and the algorithm is well defined, but it's just sort of like, yeah, I just don't have that piece of code yet. And some of this might be taking data journalism as an example, generating graphs or charts or something where, maybe the newsroom already has code to do that, or maybe in some examples, like, calling APIs, or, doing QA on data or something like that. It turns out that instead of having the LLM go over, hundreds of megabytes of financial data, or like BLS data or something like that, saying like, no, I'm going to have, Claude Code write that for me. And so I read an article, I believe it was from Axos. Yeah, the CTO of Axos. It was like, they're using Claude Code to write a lot of internal tooling really quickly. And so I kind of gathered from that I don't know how much they're using LLMs directly in, the journalistic process, but they might not be doing too much of that. It might be really leveraging the idea that, especially when it's the data journalism side, that there's parts of data journalism about deciding what story to write and inspecting data to kind of find novel things that might, it's still like a human is really valuable for that. But a lot of the side where a data scientist wants software written, having Claude Code do that for you, it seems like a very reasonable solution at this point. And then finally, these last two, like, don't overestimate the idea of saying like, well, if the LLM isn't producing the output I want, like actually writing the articles themselves, we'll see in the agent. But in this example, but I don't find that the style is very good. And maybe if I had a very large style guide or style book that I was following, the LM would do better. But at some level, I think we're in this transition period where if you have a skill like writing, and I felt this way about software development over the last couple of years, where it's like, I don't want to write software anymore because I know that the AI can do it. And even if it can't do it right now, it'll do it in the future. But I finally came around to saying, like, if I don't keep manually doing the thing that I'm good at, I will lose that skill. And then, a year later, when I've lost that skill, I might have a different view of, and so I kind of feel like, keep in mind, you can always actually just write an article. Like, you're not allowed to do something manually just because AI exists. And then finally, and this is just a more general idea, that like everything, if maybe you don't need to do the thing in the first place. Like, you really just saying like, I'm building an agent and there just wasn't, we could just not do that. And that's more of a general, philosophy. But I just wanted to kind of throw those out there as alternatives. All right, and now the last one, we're talking about risks and then testing. But I wanted to kind of, there's so many risks involved in AI that I can't really cover all of them. But I think this kind of broad categorization of specifically going from just having models, just having software, to now having agents, sort of what are sort of all the mitigations that are possible. So as an example, if we have like hallucinations or a lot of the model level risks, and that's where something like, okay, for an individual prompt has to do maybe some reasoning and it's not producing the right output. This is where evals come in. This is where you want to have a good large, maybe even thousands of examples of input and good output, ideally. And really, especially for regressions where you're modifying prompts or maybe evaluating new models, it's very, very important to have evals to constantly check for regressions. But I will say also, this is again where a lot of effort goes in. For example, in this demo, I don't have any evals for the prompts. Like I didn't, that wasn't something that I said I had the time to put that in for this example. And that's where I think, you need domain experts, because you really, really, especially, take something like writing an article or even like style changes. I'm not that, as not being the domain expert, it's gonna be hard for me to come up with the evals in a domain I'm not in. And then this is also where I'm gonna call it more traditional data science roles, and even, QA is still important because we need really good evals. The next kind of category of mitigations is guardrails. So evals are specific to your use of models. So there might be some evals like human eval and other evals that are designed for evaluating models against each other broadly, almost like a scoreboard. But you also, you need evals where you are, as sort of the owner of the agent or owner of the prompts, are writing evals. Guardrails are more commoditized at the level of basically saying, for example, data leakage. There's a lot of guardrails that can check for personal identifiable information. So you could say, are there credit card numbers in the output? Are there, phone numbers, something like that? Also, for toxic language, also jailbreaking. So guardrails, where a jailbreaking might be where you say, the model itself doesn't want to say how to bully, for example. But if you say in the prompt, well, I'm writing a play where somebody bullies somebody, and explain that, okay, that now you've jailbroken that model to go against its own rules. And so these are where, guardrails you kind of like attach on. And often when you see any of these providers of agent tools, that you kind of get those guardrails from them. And so the most common are going to be, guarding against on the input side, against dangerous input, and then on the output side saying, are we sure we're not outputting anything that we shouldn't be, like personal identifiable information? Okay, then this idea of like human in the loop. So, if we have something where there's a lot of risk involved, and so I think of, anything that's high impact, anything that would be like, we're writing code and we've got to worry about cybersecurity. At some point, we want to have a human in the loop. And when we get to agents, instead of saying, like with a chatbot, we're in the loop at basically every step, we won't see this in the example, but I just want to mention it. We can have certain points in that flow where we explicitly say, okay, after we run research, let's say, we explicitly ask for confirmation from a human. And maybe in our example, it's like, we send an email to a person that reviews that research, and then only when they respond to the email or go into the app or something and give confirmation, do we continue with the rest of the writing process. And then so those three protect against a lot of problems. These last three are more about how do we sort of not so much the risks of what our agent can do in the outside world, but more of the risk of the agents just failing and being unreliable and not being able to be very long running. And so what I found is when you have workflows that just aren't running reliably. So an example of this we'll see again is word count, where an important idea of how the manager is going to say, like, how do I know when to move on to the next step? How do I know when I finished writing the first draft is that it meets the length requirement? Well, if it's not working very reliably, we can really increase the determinism by saying, let's just write a little bit of code that checks the word count very explicitly rather than rely on the LLM to do it. And then if we also have this problem that just like any software system, the code itself could actually fail or be unreliable. We can have just bugs in the code because we're writing an agent. And this is where just traditional software testing is the appropriate solution. And then finally, sometimes what we'll find is, we want to build these workflows, and the more narrow we make them, the more reliably they run. But then we're also losing a lot of the power of LLMs. Like, we're losing a lot of this idea of saying, well, the AI can solve more of these open-ended problems. And this is where gating, and actually after we have the LLM do something and produce some artifact, we want to run a prompt to sort of check its work. And the more we put in this gating, the more we can deal with more flexible situations, because as we get more flexible, relying on an LLM to sort of check the work, rather than maybe like we'll see in the example, having some code check something that's more brittle. And so anyway, so we have all these sort of issues that come up, and these 6 sort of solutions in the tool bag to kind of solve them. And then finally, related to that, I wanted to, when we talk about testing, we really kind of have these, 3 tools at our disposal, and it's good to know, even if you're not writing an agent or something, but you're just involved in the process, how these kind of match up. And so, when we're talking about at the model and the prompt level, evals are kind of our best tool to say, is this doing a good job? Is this producing the output that we want? When we are writing code or having AI generate code, software testing, both unit testing and end-to-end testing, nothing has changed there in a way, but that is our solution if we want to make code run reliable and test code. So whether manual testing or writing tests. And then the new thing is with agents, we're going to have these workflows. And then there's this new idea called tracing that will allow us to debug these complete workflows. And so I'll show an example of this just really quickly. Basically, right, we're going to, once I show the agent, we're going to have this like manager agent run. And then we're going to run this outline agent and then go back to the manager agent. And so the trace, it basically allows us to actually debug what's happening over the course of the whole loop and all of these individual LLM calls and all of the tool calls that happen. So every time you see that post V1 responses, that's a call to the LLM. And then where you see on here, there's that news search. Each one of those is a tool call that's doing a search with a certain query. And I highlighted one specifically to kind of show the value of this, right? That I ran into early, where I'm doing some query about AI, and the output is just like I had an invalid API key, like I hadn't set up the API key or correctly. And so from a mechanical standpoint, as you're kind of developing the agent, writing the code, the traces are invaluable, but I'll also say that they're insufficient. They're only that first step, and they tend to work best with these types of errors related to tool calling and APIs and very like detail-oriented problems. The reality is, if I show you, later, I'll open the traces live, and well, if I'm taking this bottom right corner and I'm throwing in a 3,000 word, article, like it's not sufficient to be able to see what's going on. And so I think with any, production agent or anything really complex, in addition to tracing, which really comes out of the box with any of these agent frameworks or SDKs, it's really going to be important to build tooling on top of that. And I think this is where we see this sort of like snowballing of, if you can reliably use Claude Code, for example, to write code, then suddenly, okay, using that to build the tooling to, and you kind of get this feedback loop. To almost have, when you hear like agents build themselves or something, it's not, I don't know, it's not some magic thing. It's this idea that, okay, we're having them write code, and the code is actually what's doing the agent work, and allowing humans in the loop to be way more productive, because, being able to audit and test and debug is just as important as building something. Okay, so yeah, before I go any further, that's the whole presentation, and then I'll jump to doing the demo, and then we'll do a lot of Q&A. But if you have any questions now, let's get to them.
Yeah, thanks, Steve. There's a question, maybe, unless you're showcasing the demo, but Mitch was asking if you have found returns on multi-agent systems with roles versus multi-single sessions with documentation, and he was referring to this guy, Gadsden project, Steve Yegi, which has it's a team of agents, I guess, a mayor you talk to oversee sub-agents, watchdogs. So I guess that the idea of the team of agents working together, and you basically have over hierarchy, if you're familiar with that.
Yeah, I would say that the short answer is like definitely yes, but a lot of it has to do with the how we actually define these terms, because I think what you're seeing is this back and forth between, on the one hand, if we want users to understand what we're selling them, referring to the whole system as an agent actually, can make the most sense. I would say even when we look at this example, what we'll see is technically each one of these finite state machine nodes is its own agent according to the agent SDK, right? And so in like a very technical sense, this agent that I'm going to show you that writes articles could be called an agent team or a multi-agent system, but I don't think it really qualifies. I would just call what we're building here an agent where I happen to be in sort of inside of this outer loop and the inner loop using the agent SDK. And so we call them all separate agents. For example, for the tool that I'm building for semiconductor design, it really will be, it's an agent team. And the idea is because, I have one agent that's writing low-level software like assembly, and another agent that's actually doing design of what's called RTL, but basically like the actual gates and digital design, and another agent that focuses on the instruction set and the CPU in between those two. And so I think a big part of once you start, another way to put it is if I think of it as like the way that if there's an interface between two agents that is really clear to the end user, where it's like, oh yeah, no, I want to have an agent here that outputs some very specific type of artifact, and then that hands it over to another agent, it can be really, really helpful to model that even in a user-facing way as two different agents. What I found though is, I think like a year ago, I tried the multi-agent thing way too extreme, where you're kind of thinking of it almost like employees, and you're like, oh, I have an agent that focuses on, writing the code. I have an agent that focuses on writing the documentation. I have an agent that focuses on, something else. I think about a year ago, that was definitely seemed like it was going to be the most popular pattern. And the reality though is, if all those things are tightly coupled problems, it just doesn't solve anything. And if you say, oh, I've got this chat bot that all the agents are talking to each other, and I've seen that in some example projects, they tend to go off the rails. I mean, I remember reading one example where someone's like, oh, I set up all these agents as if it's one employee at my startup. Each one's an agent. They talk to each other. And I mean, he spent hundreds of dollars in tokens where they're like planning a vacation because they were like, hey, we're in the chat and we're talking. And the more he tried to like steer them by being like, stop talking about a vacation, you're not real people, like the more that vacation showed up in the context and the more that they kind of got into these, side conversations. And so I think, yeah, I mean, I definitely think it's sort of like dividing stuff into modules, or like, I'm going to have some app that's user facing, and how does the user view the product, right? And that's where there might be some sort of obvious way, depending on the domain, to kind of split that up into parts where people already kind of. So for example, maybe I have a customer service agent and I have an HR agent, and okay, having those two be totally separate makes sense. But then I've seen particularly like I think it was the Microsoft agent framework documentation, I played around that like 6 months ago. I mean, it was an example where it said, okay, we're gonna have three agents. We're gonna have the agent that deals with the customers in the chatbot, and then they're gonna hand off to either a booking agent or a it was like some other flight related slightly different thing, something like, oh, check your existing flight status agent, I think it was. And at the end of the day, I think really Anthropic, maybe it was a year ago or 6 months, it really shifted to using skills. So we'll talk about that later, but like skills.md is a way where you basically have folders that basically represent more complex kind of tools, and where the nature of skills and kind of the reason it's so powerful is you don't load the entire skill folder into the context. So instead, the skills basically have three parts. You have like a name and a description that has a very short limit of like 100 or 200 tokens. And here I got it open so I can, yeah, here we go. It's the idea of progressive disclosure. So the metadata, which is just the name and description of each skill, is only about 100 tokens. And then the rest of the skill.md file is about under 5,000 tokens. And then everything else you need to do that skill, it could be really, really big, is in folders, is in these subfolders. But the big idea then is you can have hundreds or thousands of skills that are all loaded simultaneously. So I think of HR as a really good example of this, where let's say you had, you have a number of workflows in HR, but each workflow might have to, get data from all these disparate sources just to show the history of the HR department. This is where you might have 100 skills, like, look up the current, employee status, or look up, withholding or something like that. And you might have to try 2 or 3 tools because, for this employee, you look up using this one tool in the legacy database because they've been an employee for 20 years and you don't find it there. So then you look at the next one. And so I think at that point saying like, okay, we've divided the HR agent into, a bunch of different agents that's then facing like an HR employee to use, it just doesn't add that much value. And so I've found, at least this is, and this is why there's so many different patterns. And a lot of it is once you get something working for you personally, it's sort of, I think it's going to be it's what you stick with. And I like the finite state machine pattern the best, where you kind of view it like, sure, we have all these subparts and they all definitely have their own prompts. That's the big thing. Because I almost think there's three ways of doing it. One is you have this one big mega prompt that has to solve all problems that your agent is going to run into. And you just run in this loop, always calling that one prompt. And I don't find that works very effectively. One, it always uses a lot of context. And then it's just hard for it to follow instructions because you're not sort of limiting the scope of the instructions. And on the other end of the spectrum, you have a much more sort of like very large system where the agents are totally independent of each other. But the reality is there's enough coupling that it's hard to get, it's sort of like, I think having many agents would be the ideal, where there's this very loose coupling between the agents. But in practice, what I found is I want to solve a problem in a workflow. I need to just get it to work, at this point. And I need to separate those prompts out, but I don't really get the utility of actually splitting those into many agents. And so again, with what I'm working on for semiconductors, it's sort of like, I'm going to have individual prompts. I'm going to have the finite state machine pattern with a bunch of different work steps to build a workflow and have multiple workflows that then I call one agent. And then for the whole product, I'm going to have agents that are very much based on like, literally in the app, it's sort of like, no, open this tab to see the output of this particular agent, chat with that agent. And often that agent, it's very much like, well, you probably want an agent to have a GUI dedicated to that. So if I'm visualizing, if for example, let's say an agent that's doing, the data part of data journalism, and a different agent for actually writing prose and articles and stuff. The data science one might have a lot more visualization and data tools that open when I'm engaging with that as like the human in the loop. And then, so I think the separation, it has to do with kind of, having those 3 levels and then separating agents as like a user-facing concern. When you really call them, to really call it like a multi-agent system. But a lot of this, it's just terminology. Right.
So just also to Ross' point about the tokens cost, is our skills a way to avoid running into too much tokens? Is that the idea? It's kind of a, or
my opinion is not really. I mean, so skills are great because it allows you to do a bunch of things, but it's this weird, trying to think, it's almost like induced demand or something. It's kind of like the more that the skills can just do stuff, the more that you kind of feel like, okay, I can have these loops run longer, but there's sort of this like, there's this exponential growth in the complexity of the state as the more iterations you run, right? And the longer running it is. And so the more you're trying to keep it on the rails, the more you just use an insane number of tokens. And so frankly, I mean, you're definitely seeing it with stuff like OpenClaw and Claude Code and, these like leaderboards for token usage, which to me is just a crazy, I get it, but it's also kind of crazy to me of incentivizing your employees to just increase costs to your company. But, so I definitely agree with that like, I find, it's the more narrow that you try to set. I have an agent that builds something that has high utility. And then, that's how you're going to keep token usage down. And the more long running the agents are, the only way they can be long running is to use tokens less and less efficiently. And so I definitely agree with the sentiment that, for a lot of use cases, if you think of agents as just like, I don't want to do that, the AI can just do it. And then like Manus, I think, was a good example that Flavius and I both, tried, where it just seemed, I mean, when that first came out, I was like, oh my gosh, this can just do so much. And then I looked and it's like, I'm spending like $50 an hour, $100 an hour. And it's not as if the output, and then when you actually look at what it's doing behind the scenes, I mean, it's just going back and forth, trying everything, running yeah, I mean, especially when it comes to, I think there's a big worth talking about now too, which is this distinction where, I view kind of journalism as actually on one of the more difficult, on this difficult end of the spectrum, because it's hard to create this sort of ground truth. And coding is close to the other end of the spectrum, where, when you write some code, if you have Claude Code, write some code, and then it runs that code, and that's where the skills come in to actually be able to open a PDF and do, just do whatever you need to do to get it to run. But okay, now it fails and there's some error message, and it's going to use more tokens to try to rewrite that, and it's going to produce more output that you have to review. And so I would say not only the token usage flattens the hype, I find that I'll just be honest, like, I don't really enjoy using Claude Code. I don't really enjoy using Mistral Vibe. It's exhausting. It's like having a junior developer and just reviewing their code and then you can't explain to them, write less code and just teach them. And so I definitely agree with that. And that's where, again, coming from the semiconductor side, it's even further than code, in the sense that I can have simulation ground truth. And that simulation often takes a long time to run, where it's kind of the only reason that, tokens aren't the limiting factor, because there's already this ridiculously compute intensive part of making chips that it's going to be invoked by the LM. So it shows the same cost problem, right? In that, like, I'm automatically now using way, way more compute resources.
Right.
But so I think it's domain specific. And again, getting to that ground truth is sort of the only way to keep those token usage down.
Yeah, and maybe that's for later Q&A, but then you have this position that, well, you can run the model on your computer, right? Of course, it requires some more maintenance and some kind of skills. But you have the whole YouTube influencer was like, just buy a Mac Mini and run run Llama and other DeepSeek, and then you can have your agent at eternity.
Well, so I think that's a great thing to bring up, because I think it's kind of like yes and no, and I think this is where it comes into that ground truth. So, for example, in this example of writing an article, I don't think it would be very effective, because while you've reduced the token cost, because there's no objective way to say that the article is better written than another article, you as a human now have to review every single thing that it outputs. And by doing it in a local model, you're using a smaller model than the frontier models, and therefore the quality of the output is worse. And now you as a human are using more time to review that and fix it. And that, in the example of writing or research or any of this journalism stuff, I feel like that's the big bottleneck. And therefore, I wouldn't advise necessarily running on a local machine for the example. I'm going to use like GPT-5 in the example. But yeah, for the semiconductor stuff, I mean, a big selling point I'm trying to make is it is on premise. It just runs on a workstation. This runs on like 128 gigabyte NVIDIA workstation. And part of the reason why I can make that work is because, again, the ground truth is so aggressive, right? It's because it's like, no, when it outputs something that's wrong, I'm not in the loop to check it. The simulator is running in the loop. And even though I say, simulation can be very, very expensive, a lot of it, like linting, a lot of these early steps in the simulation will catch most of the errors even after running, for 30 seconds. So if it outputs some syntax that's wrong for the code generation tools, like immediately it comes back and it's like, okay, that's wrong. And then even I analyze stuff like, okay, to generate basically the size of the thing that I wanted. If that's way off, it's probably not doing the right thing. And so a lot of these sort of like reality checks allow you to then figure out maybe how to use these medium-sized models. So I tried the spectrum. So, for ChatGPT, we're talking about trillions of parameters and proprietary. It's totally opaque at this point. On the other end of the spectrum, you have stuff like Llama and Ministral, which are like 3 billion, 7 billion, 14 billion parameters. I thought I was really excited about those, and I found they're too small to make it worth the effort for the engineering effort up front to try to get them to work. And that frankly, I found that sweet spot of, I'm a big fan, I've been using Mistral Small 4 recently, just over the last few months. And I've been really happy with that, where it's a 120 billion parameter mixture of experts model. And there's a lot of those in the 100 to 200, 70B, 200B models that will fit in local systems. And then you're not using, it's not this ridiculous, token usage or even energy usage. These workstations, I don't know, the GPU is 140 watts as opposed to 400 watts for, and then the other part too is you don't have to run them 24/7, right? I mean, once you're buying a workstation that costs me $3,000 or $4,000, and then saying like, okay, well, if I'm running this for 10 or 20 hours a week, I'm still getting my value. It's like a normal computer, kind of thing. Yeah.
Thanks.
Yeah.
Steve, sorry for distracting you from your next.
No, that's exactly what I wanted to make sure to kind of cover stuff before diving into the example. All right, so okay, so I'm just gonna let's just start by running this and kind of then talking about what it's doing. So basically, I'll start by basically I have a file here that has a very short. So rise of hyper specialization in medicine, impact on patients, doctors, medical systems, insurers, et cetera. So the idea is I basically want my agent to write an article, and I'm going to give it a word count that for this topic. And so that's sort of the problem. And then if I have so I'm going to do a 1,750 word target, and I'll just start this running and then kind of talk through this. So okay, so the big idea is we're going to call tools. We're going to run in a loop, and so what is we're starting by running this outline. The manager is running in between every one of these steps, and when we look at I'll show you the code next, and we'll actually see what the manager does. But in this output, I'm not showing the manager as a step. I'm just kind of outputting, the individual steps, and then there we go. So and then for each step, basically. They're a little different. The outline just runs once, and then all the other steps after that will just sort of keep iterating, adding to the existing document. So if we're doing research, it's going to call our news search tool, come up with some queries based on what the topic is, and then run the news search tool. The news data.api, a lot of these news search tools I found are pretty expensive. I'm using like the free version, which sort of limits you to searching just in the past, things like 48 hours or something. But I found that with this I handpicked a few topics that seem to work pretty well. And so one thing, this gets this idea of, so I'm using GPT, and I'm also using the OpenAI's Agents SDK. And so one idea is even with each of these steps that I'm doing, the Agent SDK allows it to call tools more than once. So it's not necessarily one-to-one. It's almost like it's running its own smaller loop with each step. And in this case, it can call, a tool a small finite number of times. So in this case, it called the tool 3 times and then went ahead and added that to the research document. And one thing to take away from this is these agents can also take a long time to run. I mean, that's the thing about saying, okay, we have this long-running agent. There's not so much in this process that's parallelizable. So the latency to run this is pretty long. It's going to take like 10 minutes to run this. So I'm going to do almost like a cooking show where it's like, all right, after we see a few of these come in, I'll switch over to one that's already run and kind of see all the steps. But generally speaking, you can see, okay, it ran research 3 times. It added to that research document each time. The word count went up, and now it's starting to write the first draft. And one of the ideas here is, if I directly just use an LLM rather than an agent, it would want to write the entire article at once. You say, I want an article, it's going to write the whole thing. And what I've found is, right, if you want a really long form article, 5,000-10,000 words or something, it's going to always, kind of force an outline or not get the level of detail that you really want in writing, or even be able to kind of follow the style guide. And And, by breaking this up into little steps, we'll see later, the instructions basically say, output a certain number of words on each step. In this case, though, and this is where we'll also see that if I were going to put this in production, I want to do a lot more of this prompt engineering and state management to kind of force it to follow what I wanted. So, first draft, it wrote all one shot. Now, the second draft is doing a better job of, outputting, but man, it's not increasing the word count. So this is an example where it's kind of broken. And I'm telling that because it's not, the word count's not increasing. It's stuck in an individual node. And so when we get to the code, I think it'll be easier to it'll be a good example where we can dive in. All right, now it kind of, for whatever reason, fixed it, that particular iteration decided to kind of finalize the second draft, and now it's moving on to copy editing. So we'll do copy editing, doing a final draft, and then review that. Let me now kind of switch back. Well, I'll just let it finish. I think it's all right. So I think this is important. I even we'll look at the individual documents that it outputted, but I even made sure to print like this, final review. I wanted this really like pass fail. This is another example of like gating, where it's like, okay, I want to know, did it pass or fail? And if it passed and it had the output okay instead of failed, I would have sent the article off as an email. In this case, it didn't pass, and so I didn't go on to the final step of sending that email. And what I found actually is, when you're first building agents, focusing on these checks is more important than focusing on getting it to work correctly. Because once you actually, even, getting an LM to correctly check stuff is not trivial. I mean, it's easy for it to confidently say everything was exactly correct. In this case, right, okay, I very explicitly asked, check the word count, check for formatting, a few things. It fits the topic, the tone, and here, the target length. The only way I can reliably count on the word count target length being correct is because I actually have code that checks the word count rather than the LM itself. And that's something I put in very early as I was developing this final review part. And then additionally, it says, okay, it fits the word count, but it required a very specific format of output. In my example, I just wanted to output Markdown so that it's easy for us to look at. And it was able to catch this error that it's like, oh, you skipped over the title section. And so that violates it. And so, okay, we fail, right? And so that's sort of, the importance of that final step. But let me now pull up one that succeeded. Let's see. Okay, so this is that same prompt. I gave it a different word count. And this also speaks to I'm gonna say like the brittleness of agents, especially, again, this is an agent that I put about 2 days of work into getting this to work. And I found that as I tested among a bunch of different word counts, at very high word counts, it breaks for a bunch of different reasons, and that would have to be fixed. Here we have a 2,200 word count. It, was able to get that output correctly. And then we're looking at this and say, okay, it's addressing a lot of these ideas that it brought up in the outline. This is also, but you do have to be careful of like, I asked it to use the AP style book, but you have to remember, it doesn't actually have access to the AP style book. That's not one of my tools. It would be, and I was looking at, maybe including that, but it's, AP owns it. I don't own the AP style book. But at the end of the day, it's like, yeah, this is consistent with the AP style. Now, on the other hand, there's so much on the internet, I'm assuming, about rules for the AP style book that there's probably quite a bit in the pre-trained data that is reasonable, but it gives it this overconfidence to actually say like, yeah, this is consistent with the AP style book. Doesn't actually mean that if you like went through and actually reviewed the final output, so here's our final output, the content might be right, but this at the end of the day is not in the format of an article, an AP article, right? Like, and I didn't exactly ask it to. I kind of gave it this, general one-line thing, being like, use the AP style book. And then, so you have to be careful that the more you instruct it, an agent, to do something, the more aggressively it's going to go back and tell you that it did. Even, it doesn't necessarily mean that the check to do it was any more reliable. The harder you ask it, the more you kind of say, please do the thing. You haven't been doing this correctly. If it doesn't really going to guarantee that when it says, okay, I followed the style guide, that it followed the style guide. And that's even more of a reason why having agents that you put a lot of effort into and then keep subdividing the problem more and more, which again brings up this idea of now you're using more and more tokens. That's just the reality of, where we are with agents, I think. And so I like this as a topic, right? Because I think it's relevant. It's also a relatively complex one that requires research and is, kind of well suited for a long form article. And again, we won't go through the whole thing, but it produced a 2,200 word article. It's not, so it kind of did what it said it was going to do. And, if I go from the first draft, one thing I also noticed, because I don't have a really big style guide in here, is it's defaulting to writing the way that the LLM wants to write. And then later when you ask it, is this written well? It's kind of just confirming the way that it already did it. And it's almost always saying like, yeah, this is really good. I mean, I think where this approach of breaking this out into writing drafts and everything, it has more utility is where you actually have like a way more complex style book. And then in the first draft, you're focusing on outputting all in one shot. And that is allowing, to make sure that you have, organization is correct over the whole thing. But then as you actually edit, actually saying, oh, we're going to break this down paragraph by paragraph or even line by line, and asking for very specific things. Like, I think one thing I did put in was like, don't use M dashes, because that's just a really, for whatever reason, the LLMs love certain, stylistic structures. And even just saying like, okay, let me get a list of the most common, things that make it feel like it's written by an LLM, and then very explicitly say, don't do that, is reasonably effective. So anyway, I'll go back. I'll kind of go back to this in order. So, first we created this outline. The outline, wrote the lead, and then it, kind of like an outline, it broke this down into bullet points and kind of said, here's how we want to talk about, hospitals, insurers, it seems pretty good. And then second, I just, and again, this is where if I were really building this for real, journalistic use, I might know more about like, well, what's really the process that we want to go through. And maybe we say, okay, well, actually we do some research, then we do an outline, then we go back and do more research. Here, I'm kind of keeping it simple. Once we're done with the outline, we go on and do a lot of research, and then we kind of move on and write the article. Here's where you can see doing that. It actually took the output from the tool. So I want to focus on that for a second. If we didn't have that tool to actually do news search, these LLMs can do web search, they can, but we wouldn't necessarily get these same results. And for something that's, another example here is a, news digest about oil prices, right? This is where like a web search might be okay, but we really probably want to do a news search over the last 48 hours and get some citable sources. The API that I'm using doesn't allow me to get the full article text under the free version. So it does make it a little bit less useful, because the research basically just gives the headline and the short description of the article. But I found that in a lot of articles, that's actually giving enough information to at least, be useful. So that, in this one that's very news research oriented, it's able to write with, details from the actual news search. But anyway, so, we start with an outline. We go on to doing research using that tool. We then, in one shot, have it write this draft article. And I think this also speaks to like the fact that this actually has a lot of headings and matches the outline better. That, again, if we're going to actually make sure that the final draft is, there's no reason to think it won't actually get worse, and we won't have this divergent behavior. The more we run an agent in these longer and longer loops, if we don't explicitly prompt it to spend most of these tokens and these iterations on checking its work and making sure that at every step we're improving, it's much more likely to actually degenerate and get worse if we just run it longer, right? And I think this gets back to like, yeah, the token usage can get really, really large when you start saying like, okay, first I just get it to do something that's not that great, and then as I try to solve all of these failure modes and fix all these problems, it tends to be hard. I mean, I'm thinking comparing it to something maybe like software development or writing, maybe is a better example here, where, you know, often you write a first draft that's really long, and then you edit it down, and then maybe you add stuff and then edit that down. And there's this ebb and flow of making artifacts bigger and then smaller, right? And sometimes it's called like the double diamond design pattern, where you start with a very small design, you know, increase the scope a lot, and then compress that scope, and then start implementing. It gets really big, and then you make it small again. And I found that it's very, very difficult to do with agents, because the LLM is going to kind of do what it wants to do unless you add more prompts to get it to do the checks, to get it to kind of, so when you know, in order to get the state, you know, in this case, each of these drafts and the research and the outline to keep moving forward in the right direction, you almost always have to use more tokens and more prompts to solve every problem. And then that leads, again, to this sort of like complexity explosion. And again, I think that's why I just keep emphasizing this idea of ground truth, that like everywhere where you can find ground truth, like that's what you want to attack very aggressively. And depending on the domain, that can be, you know, really vary. And that's why all the, you know, unlike even writing software, like very domain specific, I feel like writing agents, you know, writing a legal agent or a medical, you know, these are all just very domain specific that require you to really think about like where can we actually invoke a tool that would actually check to see, is this really true? And again, this is when I worked with, you know, with Flavius, kind of doing a research investigation. Like you know, journalism, I underestimate how difficult it is to kind of know that anything, you know, it's like every time you want to prove something is true, you have to use, you know, critical thinking, and it's hard to just turn that over to a tool, right? And so I think, again, that's where like Claude Code, the fact that it can at least run the code, it can at least find errors that are syntax errors, or you know, inspect the output and say this wasn't what we wanted. Even then, I find when I use Claude Code, it doesn't mean the code is written the way I want it to be written. It doesn't mean that there aren't you know, subtle security vulnerabilities, or worse, sort of like bad architectural decisions and just sort of this bloated code that keeps growing and growing and growing. I mean, that tends to be much harder to where you know, if I actually had a real junior developer, I would, you know, do code reviews, and hopefully every time doing a code review, they'd learn in much more of a deeper way about what sometimes called like a theory of the program, and these sort of, you know, programming best practices and how it relates to the architecture we chose, or, you know, to kind of improve that. And, you know, one of the things is when you're going in and just, you know, saying, okay, it produced the wrong output, now you go back and fix something, you've got to kind of get to the root and say, no, I've got to actually go back and edit the style guide that I gave it, so that it's at least going to do that a little better next time. And just as I'm on that topic, you know, I just wanted to put this in here to show you, like, okay, your style guide would go here, but this is not a style guide. This is a 5 bullet points to kind of as a placeholder, and it's part of the reason why basically the output of all the drafts is pretty similar, and why it's outputting what ChatGPT wants to output, right? There's not, you know, but if you notice here, the fact that I give it some specific instructions of saying, like, I want 2 or 3 levels of hierarchy, I want to do it in Markdown, and that was mostly so I could, you know, preview it in GitHub. And then if you notice, you know, by having this codified in a guide, it also allows that review step to look at the guide and say, okay, where did we not, you know, follow the rules correctly? And so that's, yeah, let's see. And then, you know, finally we keep iterating, get to the final draft. Again, not that much changes, and we get this degradation. Let me also show you the state object, because this is sort of, you know, this is what's internally being passed to the next step. So as we go through, we say, okay, first we're going to do an outline, and then we're going to, you know, have the manager decide what to do next and keep doing that loop. You know, we have to, instead of passing the entire just raw chat history, we take the raw output of the LLM and just keep appending that to an array and passing it back. Here, we're managing the state more specifically. So one, I'm always keeping the original user input in its own section of the state so that I can use, when I have the instructions in the prompt that we'll see in a minute, I can more specifically refer to these. I'm keeping very explicitly separate this idea is at some point we're going to be done, and that's going to cause the loop to actually exit. We're keeping track of what step are we currently doing. So that's the finite state machine state. And then because I'm not keeping the entire chat history, I want to have a general idea of like what steps have we already done. And so I am keeping this comprehensive history of all of the steps we did, so I can give instructions like make sure to run research at least 3 times to the research prompt and know that that's actually going to be included in the state. And then basically for each for each one of these documents and steps that we're moving along, I did keep it pretty simple. We have the actual content that will keep being appended to by each step. And then this word count that I keep very separate and explicit. And that's going to be generated by code rather than the LLM, because that's going to be more reliable. And that's going to be like a key part of moving this process forward is having those word counts. And then finally, for the AI review, I wasn't worried about word count, so I didn't include it. And then finally, again, saying like, okay, did we pass the review? And then finally, were we able to email it off to the person? And so in this example where it passed, it looked like this. And we see, we ran research 3 times. We had a couple for the first draft, a bunch for the second draft. And, in another example where it, let's see, this was so this one passed as well. Yeah, so most of these actually pass the word count check, everything. But so that's that document that's actually going in the loop each time. So I think now it's gonna be the big. I mean, I'm gonna kind of show the code because I think that's an important part of getting this idea that like. Yeah, I mean, there's just a lot of, and at the end of the day, the agent is a program. Like it's a program that's very different from writing a regular program because the prompts are a much bigger part of it. But at the end of the day, it's still a program. So actually, before I go any further, were there any other questions?
Not on the substance, just about the slide deck, if you can. If you're willing
That's a good point. After the shoot, I didn't plan that ahead. I guess
you can, if Aaron and whoever wants to have the slide deck can, if you don't want to share your email here, you can drop me an email.
So I actually put the
right here.
That's a good point. So what I'll do is I'll put the GitHub repo in chat here, and then I meant to do this earlier so that people could follow along. And then also what I'll do is after the talk, I'll just put the slide deck as like a PDF and actually put it in the repo. And that way, just like everything you can just find at that link. And then I don't know, Flavius, afterwards, you want to like email that out or however that works with Meetup.
Yeah.
I don't know.
Yeah, sure.
All right. No, thanks. That's a good point. And also that'll be, if you want to look, follow my screen, but also if someone wanted to look at the code while I'm doing this, in case they, wanted to look at some other section that had questions about it, feel free to open the GitHub repo now, or look at some of the output and the examples. But okay, so I'll dive in. I want to keep, I don't want to get too bogged down in the code because I know not everybody's a software developer, or I assume most people aren't. But I think it's important to kind of see how this matches those so remember these concepts where, we're using tools, we're running in a loop. That loop is really managing this like finite state machine that goes through individual steps and using a manager. And then we've got to, figure out like, okay, how are we managing state and how are we managing the context? And so, I'll skip over kind of all the includes and stuff. But basically the first part is, we have this initial state, right? The state at the beginning where we've taken the topic and the word count and all the user input. We start with done is false. We start at this start state. There's nothing in the history, and all of our documents are empty, and it hasn't. So we always have to start with sort of this initial state, and then one of the things is, so I'm using the OpenAI's agent SDK, and one of the things they have is a runner that basically it's how you can look at these traces. So the idea is if you're using the Open API logs normally, you can see the response of every LLM call. So you see all these calls, but they're not connected to each other in a meaningful way. And so the beauty is by using this runner class and giving it a trace ID, we actually get these much more useful traces that allow us to, for example, take a single run of the entire agent and then actually be able to debug that as a whole by being able to see, okay, here are the instructions that we're passing in, for example, to the manager agent, and then the state object that we pass in as a user input, and then finally, the manager at first just decides we're going to run the outline step, right? And then when we're doing the outline, we can actually see here's the actual output of that step. So it's important, just first of all, for this debugging that we that we want to make sure that we allow tracing, right? Because it's going to be a really, really important aspect of getting our thing up and running and debugging it. So then we have this idea of this is our loop, right? We talk about how to loop. At the end of the day, for each iteration of the loop, we're going to call this function. We're going to call the manager first, and the manager is actually going to update that state object by saying what the next state should be. We're going to make sure to add that to the history. And then basically, depending on what step it's supposed to run, outline, research, first shop, we go ahead and we call that function. And then, with an example here where it's like, okay, we know we're done when we've succeeded at the final review. So at some point, we need to set the state, to actually being done. And then, here, I want on every single iteration of the loop, do some logging. And this is how we're able to kind of actually see those files as they come out. And then finally, in addition, I found like, you don't really want you could have some error where it's not actually setting the done condition, and you don't want it to run infinitely. So most of the time in practice, this is a maximum number of 100 iterations, right? There's just no case for writing this article. Usually it takes maybe 10, maybe 20 iterations of the loop to complete. So by putting this kind of healthy upper bound of 100 means that if it's getting that infinite loop, like we kind of saw before, where it was, kept trying to write the second draft and like wasn't adding anything, we could get into an infinite loop. And so some hard limit is usually good. And then additionally, I'm pausing for 1/4 of a second between each iteration. It turns out when it's actually running correctly, this isn't that long compared to how long it takes the LLM to run and maybe the tools to run. But in a case where there's some sort of bug where it's not even, where particularly like you have the API key wrong for the LLM or something like that, having a little bit of slowdown so it's not just doing thousands of LLM calls per second is helpful, simply because then it's like, oh, now I've hit my quote, my rate limit, and now I can't use it for a few more minutes, something like that. So basically at the end of the day, a takeaway is we have a loop that keeps doing this over and over again, where effectively we're calling the manager, and then depending on what the manager says we should do next, we're doing that step, logging the results, and then just going back and doing that again until we're done. So that's sort of the heart of our agent is this loop. And this is something I haven't really talked about yet, but is worth talking about is these agent frameworks. So like LangGraph and LangChain, Crew AI. There's a number of agent frameworks, and even these the agent SDK and some of the OpenAI and Anthropic tools. This is sort of the level where they seem like they could be helpful by putting on Rails, kind of managing this loop. But what I've found is how much value are you really getting out of it when you want a loop, so let's just write a loop and do this with code. So I think we're at the stage where frameworks it's valuable. Every time there's a new framework that comes out, I definitely like to read the documentation to understand if there's any sort of new ideas in them. Maybe if it's something I'm kind of excited about playing around with it, but I've always kind of come back to, at the end of the day, I need the flexibility of this being a code that I have, control over. And so for me, it's like, if I want a loop, I'll put in a loop. If I view it as like I have a step where this is quote an agent, Yeah, to me, a function call is sufficient abstraction. Like I don't need to overcomplicate this. But again, if as you know, like any software system, it gets more and more complex. The more tools you have to manage that complexity, the better. And so, you know, at the end of the day, we have our loop. Then one thing practically that I found for every agent that I've been working on is you often have instructions that tend to, you want to be included in every prompt because they tend to just be quirks. So for example, you know, in that state document, I had, you know, word count as its explicit field, but I found that a lot of these steps were still doing their own word count and estimating it. And so, you know, this almost just very naturally and iteratively came out of, I run into a problem, I go and I add some rule, I add some instructions to solve that problem. And if I kind of decide like, well, I don't just want that to apply to a single step, you know, I needed to apply this to kind of all the steps. You know, so for, you know, be sure to refer to the FSM history to keep track of what steps ran and the count of how many times the step ran. This is useful for almost all the steps where later I'll give instructions of saying only run, you know, run this at least 3 times, like I do for the research step. And stuff like, how do I want to format output? You know, don't include the file type, output the content. So, you know, general prompts. And what we'll see now is, okay, we have the manager. And again, this is where I'm using the agent class. This is the OpenAI agent SDK, and this is kind of the heart of it. And, you know, basically what I'm doing, you know, has a name, but that's more for debugging. And then I'm going to pass in instructions. One thing that's, I don't know if it's unique to OpenAI, but they have something called the model spec that really delineates a set of rules of sort of the difference between instruction system prompt and user prompts, and sort of this hierarchy of, you know, how rules are followed. And so one thing that you can kind of run into is when there's user data, for example, the article itself could have text in it. You don't want those to be misinterpreted as actual instructions for the agent to follow. And so one idea is, you know, in the instructions, when I actually create the agent, I have instructions, and then the actual user prompt that I'm passing in to the runner. So the runner will take that agent, and then a user prompt is actually the state itself. Because remember, the state is going to contain all of, you know, the research and the previous drafts and the outline and the original input from the user, right? So that state object I'm keeping separate. And so the idea is these instructions should be followed as instructions by the model better. And so basically I include that common prefix, and then, you know, decide what to do next. I mean, it's a relatively simple instruction in and of itself. And this is basically what I started with. And then basically started with, okay, let me delineate each possible step to take next and some rules for it. So I started really simply with like, okay, outline. If there's no outline written, or if we're in the start state, write an outline. And research. If the research is incomplete, continue to do research. And then as I iterated, you know, I found a few problems. So, you know, one, it wasn't going to get the history. So I put in this very explicit, even though it was already in the prompt prefix, I found like adding it a second time made it work more reliably. And then the second really big problem was sometimes it would just want to write the entire article. It wouldn't really follow when I say decide what to do next, that wasn't really specific enough. And so it would just sort of like write the whole article. And if you know, if I look at the code in the loop again, you know, the manager output has to actually update this finite state machine. And we'll see that at the end of the manager class. And that has to actually be a string that's outline. And so if I output the entire article, it breaks the entire workflow. It's not as if it can recover from that. And so when you, especially in the manager class and manager step and this final review, you know, really working the prompt to get it to work reliably is key. And so, you know, bold, I put all these, I duplicate it down below. You know, remember the output must be one of these strings. Remember you were only deciding which step to do next. To make this even more reliable, I'd not only use evals to check this, but I'd probably put this in code to actually check, like, if it doesn't match one of those strings, you know, let's throw an error, or maybe let's go back and rerun that step. And you know, but you know, the issue with that is it doesn't, if it fails the first time, getting it to not fail as you continue running doesn't just sort of magically happen. And then once you figure out how to get it to work the second time, often that change can just go into the prompt and you get it to run correctly, when you run it again. And so, so this is the part where it's basically, I keep iterating on rules I'll look at research as a good example where, I started with saying, okay, if the research is incomplete, can you do research? But what does incomplete mean, right? That's a very vague idea. And so what I was finding, at first it was just sort of like redoing the outline. And I said, no, okay, research should be in more depth. It needs to be longer. If you're in doubt, do more research. And then, finally I got these more specific ideas, like, okay, research should run between 1 to 3 times. And then finally I said, research should run at least 3 times and produce at least the word count. And this is where, I probably should have gone back and actually said, okay, some of these rules are conflicting, get rid of some of the previous ones. But I would say the process of iterating on these prompts, unlike maybe when you're using ChatGPT doing prompt engineering, where it's like, ooh, that didn't quite work for me. And then, maybe I pull a tool out of my toolbox from prompt engineering, but once I get it to work, I'm on to the next problem. And so it's not that reusable. Here, it's much more adding, sort of every time you run into issues, you have to kind of keep adding to the prompt. So these are the rules that kind of keep that finite state machine moving forward. And again, these in practice, you'd probably want this to be much, much longer, much, much more detailed, because this is sort of the brains of the agent in some way, right? That's subdividing this into smaller problems. And then finally, if we notice, I just take the output, so result.final output is the actual output of the LLM at this stage, and I just assign it to state machine. So very, very, not a lot of error checking here. And so if it's not outputting one of those, finite enums, basically finite set of strings, it's not, the rest of the agent isn't going to keep running correctly. And then just to give, most of these other ones are pretty similar to each other. So the outline agent doesn't use any tools. We have an agent, we add the prefix, and I have some instructions. The outline should be about half the length. I can scroll here. Well, anyway, half the length of the word count. So I give it some specific instructions. I run the agent using the state. In this case, I very explicitly say, okay, we're gonna manage that. We're not just sort of appending to a history of chat, right? We're actually saying this is the outline step. We're adding this to that outline field, and the output goes in the content. And then this is where we basically say, I'm not relying on the LLM to do the word count. I have a function called word count that is actually going to run code to do word count, on the outline contents, and assign that to the other field. And so that's sort of the bread and butter of what each step does. And so again, this beauty that I don't just have one big giant prompt that has to deal with every possible part of this big workflow, right? Each step in the workflow has its own prompt and therefore can be tuned independently, where then the manager becomes the most complex, but at least all it has to do is delegate to the right. So this is where the terminology, whether you call this a sub-agent, technically it is in some sense, right? We're using an agent class. We're saying this is an agent, but meaningfully, I like to view it more as, no, this is a finite state machine pattern. And this is one of the states in the finite state, or for more, maybe just comment, calling it a step in a workflow is probably just more natural language. And then with the research agent, this is the one I'll focus on. I added a lot more rules, but more importantly, here's where we're actually going to be able to call tools. So remember the big two, we're running in a loop and we're actually able to use tools. And one of the tools is actually built into the OpenAI SDKs are the ability to do stuff like web search, generate images. There's a handful of sort of built-in tools. But then additionally, so I basically say you have a choice. It can call no tools, it can call the web search tool, or it can call the news search tool. And the news search tool, now's actually maybe a good time to kind of look at that. Basically I included another file, but basically the news search tool uses news data IO API. and it uses that MCP, that model context protocol. Or sorry, never mind. To keep this simple, in the example in the slide deck, that's a good example where it actually uses MCP. It turns out that in the OpenAI SDK, their tool interface is quite similar. If you notice, it has the same, the name of the tool, the description. It has, these are is like the input schema. In this case, in practice, because I was using the free API, I'm not allowed to set the beginning and end date, so I actually left that out. And then at the end of the day, it calls this function called news search, and news search basically is what does the real work here of doing this API call, this like HTTP request to newsdata.io, passes in, we can scroll here. Passes in our query language and the API key to do the real work. And so we need the tools run code. They might do API calls. So for example, our email tool that we can see later, but I'll show you now. Same kind of idea. I use MailChimp for sending emails. And so we have a description so it knows how to pick the right tool. It has an input schema. And then finally, we have to actually have an implementation, which again, looks like an API call to actually send our subject and body and who we're sending the email to. And this is where risks and stuff come in. I think this is a good time to talk about it. That it's tempting to just get an agent to work, and the more open, there's definitely this trade-off between security and power and sort of ease of development, where it would be easy to basically say, well, why don't I just let the user put in who the email is going to, but suddenly now this is pretty dangerous. Both some malicious user could, figure out how to, maybe figure out how to jailbreak the agent and say, oh, if I have it in my article saying, send this email to so-and-so, that it might occasionally get followed, even with the model spec and what I was talking about before with the separation of instructions and the actual data, it's still an LLM, right? There's no guarantee that those things are going to work correctly. And so in this case, I might say well, no, I have a finite set of email addresses that we can send to. And in this case, for the demo, I kept it really simple, only send the email to me, and so it almost doesn't matter that we have this, but I might have a set of 3 or 4 email addresses and we kind of hard code that in. And I think this is the most effective way to mitigate risk is just be really, really aggressive and sort of lock it down and then kind of open it back up as you start realizing where do we actually gain the utility out of, allowing the tools to have more of flexible input. And that's always, I think, the trade-off with LLMs, right? They're incredibly powerful, and they're also incredibly dangerous if you just sort of let them do anything. And so those are 2 tools. Let me go back. And so basically, I'll kind of now more quickly go through, right? So we have these other steps okay, write the first draft. Again, we have some instructions. All these are pretty similar. Write the second draft. This is where the deeper I would get into this or work with domain experts, the more I'd probably put a lot more effort into these instructions and really kind of differentiate these steps. Finally, we run the final review. And here's where we, again, having code check something is going to be a lot more reliable. So here we're actually saying that first line has to be exactly okay or failed, right? And now we're actually checking by that, this is is the first line okay? If it is, we actually set this variable to true, that we've reviewed it and it's passed. Otherwise, we keep it as false. And then finally, same kind of idea. If we pass that check, then we're going to send the email for the review. And again, we have that send email tool that we call. And then finally, okay, well, if we email it off to user, then we're done for this particular agent. And just to kind of, here's my little word count function that, we saw you called before. Not a great word count function, but suffices to kind of demonstrate. And then, finally, this idea that, especially for debuggability, right? We don't know the order that these steps are really going to get called in, especially as we're working on the manager. And we need to have some, if we just sort of spit out all the output that the LLM comes up with, it's just going to be a wall of text and hard to kind of, track. And so in this case, I made sure to, okay, just output to the screen the word counts, because that gives me enough to follow, like, is it basically on the right track? And then I'm basically taking all the contents of, where the state has everything, these fields like outline, research, and then actually saving these to a file, and then taking the entire state and saving it to a file. And this is where, if I'm on the command line, I'd open up those files, or in this case, I'm able to, by committing them to the repo, able to kind of, look at them. And then other than, little timestamp to save each output to its own folder, then, okay, I go ahead and I start the whole thing running by running that loop at the beginning. So again, obviously an agent get way more complex than this, right? But I think architecturally, hopefully this kind of illustrates that even with this, 350 line small program, we're doing all those things, right? We are calling tools, we're running this thing in a loop, we're very explicitly managing state in a very like domain specific, workflow specific way, and we're really subdividing this problem. Even if at the end of the day the user thinks of it as like, okay, I have a writing agent that I give it a topic and it writes an article. Even if the user is thinking of it that way, we're subdividing it into these individual steps to create this much more reliable workflow. And then by breaking it up into each of these steps, like each individual prompt can be have its own little domain that it's working in. And then we have that manager as kind of the part to say like, okay, that's great. We have all these little steps. What actually, so I do here is the agent decides what to do next. The agent, does this. Well, at some level, that's what this manager comes in. And this does have to have like a broad view of the entire system of kind of, when to execute the next step. Yeah, so I think, let's see. So that's about it for the demo. But I think there's a lot we can talk about within that if people have questions.
Thanks, Steve, for this very thorough, detailed, but also comprehensive presentation. I guess I'm going to maybe start with a couple of thoughts and question. It seems to me like what you say about the ground truth, the building agent is not a small undertaking, and you started with the perspective of semiconductor, and indeed you cannot afford to screw up there. The cost would be very high, and on our daily life, or at least how I use Claude and ChatGPT, it's not too bad because I can always have the human in the loop myself, right? But as I am outsourcing more and more of my life to I shouldn't say that, perhaps to the agent, there is actually a cost of the review. First, because I will have to invest the time, and second is that it's getting harder and harder to verify the content, right? So like a good example is like I was asking Claude and ChatGPT to help me choose a health insurance plan, right? And how do I know if it's that plan that it picked, the cost of reviewing what Claude and ChatGPT suggested would have been higher than calling actually the health insurance itself, right? So even for the tasks that feels that are less consequential if the LLM screws up. But what I'm saying that also is when you kept mentioning a few times that Claude Code and Axios has actually moved away from LLM in some ways, right? And I'm curious to know that there are tasks that now would be especially for non-technical people like us, like me, would be perhaps better, would be advised to look at using code like Claude Code to do those tasks versus defaulting to the LLM because it's just like, right there, easy chatbot, natural language.
Yeah, I mean, that's a good question. So it's tough to know. I definitely hear a lot of stories of people who are not software developers like effectively using Claude Code. But I also have this feeling that like if you can't actually know what the code is doing, you need to make sure that you're, I'm going to say, like, operating a sandbox and doing stuff that's pretty, and I think the biggest one too is, even if you set aside sort of the security problems, the scope of the whatever the software is you're writing needs to be pretty small, so that you really just don't run into, I'm going to call it, software architecture problems. That you're just writing this script. And I definitely think, data journalism is a use case where that might be really, really prevalent. Where you might, for example, there might be a new data source out there that has some API, or you might say like, oh, someone wants to write an article, I'll use BLS data as an example. I was like, oh, we haven't dealt with that before. And then you go and you say, okay, well, there's actually not that much risk that if I try to write the code that actually just grabs that data, that it'll work, right? And you say, okay, Claude Code, like, and this is actually something that Claude generally does behind the scenes anyway. And that's why I think a lot of software developers like Claude. So even if you're not using Claude Code and you're just doing, using a Claude chatbot, basically, it's going to actually behind the scenes write code. And OpenAI has been doing this for a long time, using what's called a code interpreter. And basically the idea is like, let's say that you say, okay, grab me the BLS data, and it has, 100 megabytes, CSV file or something like that, or a zip file. I think even for some people, like when I gave a talk, I want to say quite a long time ago, kind of demonstrate that, where it's like, okay, here's a zip file that has a bunch of BLS data, and OpenAI, ChatGPT was basically like, oh, well, let's write some code that opens a zip file. Now let's write some code that extracts a CSV file. Let's write some code that, actually extracts the lines that are appropriate, right? So, and I think Anthropic has really doubled down on that as a solution to a lot of problems, where particularly where the context becomes the problem, you get better results by writing code. I think though, I compare it, I don't know, if people for like WordPress, or especially back, like 10 or 15 years ago, where it was sort of like, I remember working with people, I was doing like software, like web development consulting, and I'd always run into people that had started with a WordPress website and it worked really well. And they maybe knew a little bit of HTML or CSS, and they were able to get a website up. And then they added one feature, it's like, oh, I want to have one little feature here, and they'd get some plugin and it would work really well. And then what you'd see is a few months later, after they'd added like 5 or 10 of these plugins, and they have to manage databases and state and everything, there'd just sort of be this complexity explosion where they couldn't manage it and everything was breaking and the things didn't work together. And then they'd say, okay, let me maybe hire a software engineer, a web developer, to like fix these problems. And I would always go in and I'd commiserate with other web developers of like, I'd rather just kind of rewrite this whole thing. And like, now we need some sort of reasonable software architecture. And so I definitely think there's cases where, for data processing, for, I think an example like this, where we're trying to write an article, having it write code, maybe you could be like, hey, I want you to write me an agent that, and reproduce what I did there by just having Claude Code reproduce it, right? I didn't produce that big of a script. But at the end of the day, code isn't going to be able to deal with the language in the way that the LLM does, right? So where there's parts that really deal with the language, that's where you're leveraging the LLM. Where there's parts that have the type of complex reasoning that brittle algorithms don't work as well for. But here's a good example. Let's say you were using Claude Code and you did say, oh, I want to build this agent, and you hit that point where the word count issue is, the LLM was always, predicting the word count wrong. You don't have to know how to program to prompt Claude Code to be like, can you write the word count as a function? Like, that's an example where it's going to just do a much better job than I did handwriting what I know to be like not a very robust word count function, right? Where I just basically said, okay, every time there's a space, let's split this into 2 words, and then, say, okay, that's right. Because you might say like, actually the AP style book describes how word count is supposed to work, or something like that. And then you say, okay, now Claude Code, write that for me. Yeah.
But for beyond data journalism, as we are outsourcing a lot more of those like of tasks for everyday life and research to the LLM, and the human in loop is going to be harder and harder to keep track of the ground truth. How is it practically going to be managed. I mean, I pit ChatGPT against Claude for even basic research. Where should I, hang out for a co-working space or co-working space like in Paris, and then I will have different answers from the and you can I asked the chatbot to memorize, or the Claude to memorize my preferences, but even that you can get very different result outputs. And it's okay if it's a launch, if it's a quiet place to work, but if it's like health insurance research and this kind of, like, how are you going to resolve that? With the existing, you cannot build. I understand, like, I think it's the demo that you did was very good for newsrooms, for people like you want to have, as you don't want to screw up, right? So you need to make sure that the MailChimp is sent to the proper person, etc. But for everyday life, you're not going to build a chatbot from scratch to anticipate those possible.
So let me frame it like this, which I think ground truth is, even in everyday life, want to be thought of as like a domain specific problem, and that's part of the challenge of taking these techniques for agents and saying, oh, we can just apply that to all domains. It's something that as a human, when you do one of those activities, you sort of develop intuition about how to evaluate, I'll call it critical thinking, but also, oh, when I go book a flight, there might be some website that I trust more than others. Like, I'll give an example, like looking for hotels or something. Sometimes I'm on like Google Maps and I happen to see a hotel and I'm like, oh, I wonder how much that costs, right? But I kind of don't trust, for whatever reason, I don't know, I don't trust Google Maps pricing of hotels as much as, if I go to, Kayak or Priceline or something like that, and I actually say, okay, let me actually go in or go directly to the website of. So I'm just using that as an example of like, okay, we developed these techniques, and I guess in some domains, the domain has addressed the issue of ground truth in really robust ways. So like, take accounting as an example, right? Double entry bookkeeping has, this is a technique that's been around for hundreds of years that, really, really improves the reliability of being able to check when you have a mistake in accounting. And without it, human being, and the point though is this way predates computers, that human being with paper ledgers, figured how to solve the problem of sort of the problem of ground truth in accounting. And then when computers, in the 1950s and 60s, accounting was a big problem for computers, and they replicated those solutions that humans already had. And again, if I take the semiconductor industry or software, these things have to work or they don't work at all. And so the industry is generally, for semiconductors, the vast majority of the spend for employees in a semiconductor companies is in the verification process. It just has to be, because you have to prove the thing works. But it's not that, I would argue that, using journalism as an example, like, it's not that different. It's just a very different process where human beings are using that sort of critical reasoning. So the real question is, like, can you take maybe the techniques that you already do intuitively and codify those into a guide or a set of prompts, and then see if the LLMs can actually reliably follow that to create ground truth? Because, but again, even to say journalism is a domain, I bet there's thousands of different subdomains within journalism where people develop their own techniques to figure out how to, okay, so I did an interview with someone and they said something, and now I want to, double check that through some other interviews. I want to double check that through some background. Oh, here's some sources that I trust. And this is where you'd want the agent to do that same process. And you want the agent to say, okay, here's a reliable, source. Here's, and so, if it's an everyday thing that has high impact, I mean, you've got to make a judgment call about, and again, even the way you said, even just using ChatGPT, this is no different. Or doing search in the web now with any web browser and then getting some AI generated results. I'll give you an example that just came up the other day, and obviously you could be my ground truth in this. So I have a friend who's traveling to France in a few days, and they were wondering if they needed the PIN, for their credit card, because they're like, oh, isn't that a thing in Europe, like to PIN? And so I was kind of curious, so I just did like DuckDuckGo like search, and it came up with like the search assistant very, very confidently is like, you don't need a PIN for credit cards. And then it cited the sources. So it cited like Rick Steves. And so I clicked on the Rick Steves source to see where it cited. And it cited a forum post, like some random people on the internet talking about this topic on Rick Steves' forum from like 15 years ago. And then, but the AI is confidently saying this, and the reality is like, hey, if I really, really want to know, I might ask you, Flavius, because I know you're in France, and so it's like, okay, you're going to be, but I also trust you. I know you personally, and know that you're in for. There's all these context things that build up, and I think that's part of the gap of like, if we think of agents as like replacing humans, I don't think of it that way, and I'm not talking about in some very, very long term view. I'm talking about, let's talk about right now. There's so much that humans don't write down, and things they learn and things they pick up from context, that even the human effort to be able to codify and write those down in guides, even if the LLMs would follow those perfectly, which you see, they don't. Like in building an agent, you have to really pick a small sub problem if you want it to work. And so I think this is where, like, yeah, in something like, let's say, medical research, right? This is where I think you have to get subdomain specific and say, in this medical specialty, how do we, what sources of data do we trust? And I think on the one hand, in the short term, the solution is probably the same companies that provide reliable, sources. So maybe, medical journals, or, like LexisNexis, for, all of these aggregators of reliable data do have this big advantage of being able to say, okay, this is, if I get the data from there, I trust it. And so if you it's garbage in, garbage out. And so at the end of the day, the LLM is only going to introduce more problems in a way. Like, yeah, we can add more prompts to try to get it to be more reliable, but those more prompts still need to have access to something that is at the heart of it, something that we trust. And again, so in some domains, I think that's more straightforward. Like, if, again, accounting, I might want to have an agent that explains an accounting statement. I have a financial, like a balance sheet, let's say, and I say, oh, it's nice, the LLM uses language to explain that balance sheet. But if I already trust that the balance sheet is correct, because the balance sheet was generated using traditional trustworthy accounting principles, then suddenly I'm going to have output that I trust. If I take some, I'll point some of these AI companies, like CoreWeave, that are like, yeah, we use non-GAAP principles. Well, if I have an LLM and I have it read a prospectus from that company, it's going to kind of parrot whatever, because they put in a spreadsheet that we're not losing as much money as, we really are losing if we, followed proper GAAP accounting principles. And for everyday use, I think that's the challenge too, is everyday use isn't one domain. That's the problem. It's our interface to all of these different things. And it seems like, hey, I'm just using this for myself, but you have a million different problems that you're trying, and especially ones that just sort of emerge that maybe you haven't done something in a year, and you go and you're like, oh, I want to solve that problem. Well, you're on the hook to evaluate that. And so I don't know. I don't feel like in the short term, AI isn't making, in my opinion, it isn't making less work for people. I know the people that use AI the most, and I've told you this twice, I notice are the busiest and the most burnt out and the most overworked. And this is where I put in that, what to do not to train agent. And probably the best thing is to really take a step back and to say, do I need to do that at all? Like, is this a priority? More of a traditional way of looking at prioritizing, what you spend time on, and not thinking that, well, an agent is going to allow me to be 10 times more productive, so I'll do 10 times the number of things. Maybe we'll get to that point, but I don't see that right now, in my experience. I guess we'll put it that way.
Right. Thanks, Steve. Any question from participants here who are in the call? I guess we passed 2 hours, so 2.5 hours.
Oh my gosh, I was off by an hour.
Yeah, I didn't interrupt you because it was very interesting. But if there is any questions, once, twice, if not, then Steve, do you want to put your email and contact information in the chat? And I make sure to
Yeah,
forward the
that's the
slide.
best way to get
And,
in touch with me. Yeah, I don't use any social media or
recording.
anything, or LinkedIn, so just shoot me an email.
Yeah. You have an agent doing that for you. But no, after hearing that today, now you don't want to risk that. Yeah, thank you so much for being so generous with your time and sharing about your research and your insights. And I hope we having you again, teach us and enlighten us and warn us again in the future.
Yeah, well, thank you for having me, Flavius, and thank you to everybody for taking your time to listen to me.
Thank you, everyone. See you soon. You guys stay safe. Bye.
Yep. Bye.
Bye.